Hi, Professor Dyer here, talking about research and human development and family science. So, we've been warned that correlation does not mean causation, but how are we to think about correlation and cause? One way to approach this issue is to ask, well, what would it take for us to be convinced that we had identified the cause of something? What is required for causality? Essentially, there's three things. The first is that the two really do have to be correlated with each other. If two variables are not correlated, then it is completely impossible that one of them is causing the other. So correlation is actually required. It's one of the things. Another thing, though, is that the temporal order has to be right. How things are laid out in time has to make sense. What that means essentially is that there has to be a moment in time when the first thing showed up, and at that point the second thing wasn't there already. And then later in time, the second thing should also appear. But you have to have those things laid out in a way that makes sense in time. Finally, and this is the hardest one for us to really address scientifically, is that we have to rule out every other potential explanation for that relationship. So let's spend some time today talking about what are the alternative explanations that could exist for a correlation. There's four of them. The first one is that if two things are correlated, maybe it's a real correlation, but maybe it is a coincidence. Coincidences do happen. Things get related to each other, even though it's just a fluke. Here's an example of that. Definitive proof, that Jim Carrey movies cause autism. No, they don't. It's silly. It just so happened that the number of Jim Carrey movies was going up he was making movies at about the same time that we were seeing an increase in diagnoses of autism. It was a historical coincidence. No one thinks that his movies caused autism. But I think you can see the fallacy in assuming that just because two things happen at the same time, one must have caused the other. Now, this one we know is spurious, and so we're going to set it aside. But when we see correlations in the real world, the first question to ask yourself is, could it possibly be a coincidence? But let's move on to another example that I do not think is spurious. This is some research that I saw reported in the news a couple of years ago. Look at the headline. Grandparents who babysit are less likely to develop dementia and Alzheimer's. So the way this is laid out is the predictor is grandparents babysitting, and it's reducing dementia and Alzheimer's. They don't say that it has to be causal, but they kind of imply it, don't they? Through the order of the way the sentences are written and the little subtitle there, grandchildren can be a blessing, but they are also beneficial to their grandparents. They're implying that babysitting causes a reduction in dementia, and that's the way the headlines are written. But when we see this, we should consider some other possibilities. Is it spurious? I don't think this one is. But does it have reverse causality? What do I mean by that? The assumption that the first thing causes the second, sometimes we just need to reverse it and say, is it possible it goes the other way around? Consider this example of grandparents babysitting and dementia. I think it is quite possible that when a grandparent starts to show signs of dementia, that their children stop bringing the grandkids over for babysitting. That would be a reasonable relationship. So this is a reverse causality, and it's quite likely, it seems to me. A third possibility that one should always consider is that there's something else entirely, and it's causing both the predictor and the outcome. The classic example that statisticians like to use is the correlation between drowning deaths and consumption of ice cream. Nobody thinks that one of these things causes the other. We think what's happening is Heat, summer heat, causes people to go swimming, which unfortunately sometimes leads to drowning, and the summer heat causes consumption of ice cream. Now, it seems like statisticians really are against ice cream. I'm in California. We're very worried about forest fires here, and it seems like forest fires are also correlated with sales of ice cream, but for the same reason, right? These things are related to heat. The third factor here is heat. So what would that look like in our diagram? It would look something like this. A third factor, something else. I've suggested perhaps good health that would increase the frequency with which grandparents babysit, but it would also reduce dementia and Alzheimer's. You see, it would have to explain both. Good health, perhaps relatively young age. Those are things that could affect both what we have called the predictor and what we have called the outcome. Finally, it is possible that the thing laid out as the predictor might actually cause the outcome. It is possible that babysitting does in fact reduce Alzheimer's. I don't know, maybe it kind of keeps you young to be around young people. So a direct causal explanation is certainly possible. But the fact that there's correlation only really means that there's a co-occurrence. And so we should not race to the explanation that the predictor causes the outcome. We need to kind of stop and think through the other three explanations that I've offered as well.